This application software demonstrates the data mining concepts of clustering. This is implemented with the Chicago crime dataset. We have implemented on Eclipse, Eclipse Rich platform. All we have to all we have to do to run an application is to just run as a Java application, and you can see the GUI part that for the clustering. Here we have options like run the location based clustering, the work which we have done, and then the second one is crime validation indices to check the validity of the clusters. To load in the data, we have to choose a file, and then we can select the type of the algorithm, and then we can specify the number of clusters and choose the distance measure. Here we can choose the validation indexes. We have given 5 choices of indexes where basically the clustering is validated, and then just click to get the values. To load the dataset, you have to tap on the edit and choose the data file, and it has to be pre-processed. We have already pre-processed it, so I'm going to select the data file to do the clustering. And then the file is being loaded there, we can see it, and then I'm selecting the algorithm, and we have chosen to cluster it with k equal to 10 and with the Euclidean distance. All we have to do now is to just tap on the start clustering option to run the algorithm, and here we can see the results of the clustered algorithm from 0 to 9, and the data points shown are from the 9th cluster, and below we can see the total error. As a Euclidean distance, we have calculated sum of squared errors. Now as we have run the algorithm, I would like to check the validity with any of the validation indexes. I have chosen DB index as a cluster validity and click on calculate to get the validity index value, and it gives 0.7. Now to visualize the data, you have to select an option visualization of data from the edit. This gives the geographical points and the clusters. You can see the 10 clusters with the count of each cluster being done. There are 10 in Ember. We have used the Google API for this in Java. This gives a broad idea of the count of the crimes within the clusters. We have used k equal to 10 after seeing the results of the elbow knee method, which gives a substantial amount of good results, and then we have also used the C index, DB index to reanalyze the decision is right or wrong, and then to interpret and analyze the results in more detailed way. When you tap on the map, it takes you to the Tableau, where I have prepared a sheet from 2014 to you can see the reports as we have fed it in the CSV file, which is an output from our algorithm. And you can filter your results taking into consideration of the 2 filters above, and you can see at each you can select each beat or district or the locality and check the crime rate in that area, and have a picture of the statistics of the crimes where we have classified with the violent, property and other from our data set.
Hello, this is a demonstration of the C4.5 algorithm and interface that we developed for the data mining project. Let's look at the source code first. So there are two main structures at play here. One is this C4.5 node, which can hold other nodes of its type right there in the children. It can possibly have a comparison value for when you're traversing the tree trying to get a classification. And for each record, you compare it using this node comparison. And it could be one of these, and we'll compare it to this comparison value, as we see down here. Depending on this type, we return this Boolean value or this Boolean value. And that's the decision that that node returns. Or rather, that determines if we should go to this node or not. It also keeps track of which attribute is being compared at this node. It keeps track of its parent so that we can traverse up the tree if we need to. And lastly, it has a reference to a seed tree, which itself also is a container of nodes, and it keeps track of just the root. It has a list of decision attributes, which is each thing, each column of the data set, which has a name, a type, which is either discrete or continuous, and a range, which is just a minimum and a maximum value that we use elsewhere. I've defined a bunch of utility types, some helper functions such as stuff like getting the mode or the split information or the entropy of a given array of values. And this is a whole class to run the algorithm. We do recursive calls to this split function, and then as for what I ran the algorithm on, I decided to use a subset of all the class attributes. Since there were 33, it really didn't perform well at all. It got like a very high error rate when I tried it on all 33 of possible class attributes, which is the crime type. So instead I narrowed it down to a list of about 8 right here. And I wanted to see if there was any correlation between these attributes that aren't commented out, the month, the time of the hour, the location description, and then the latitude and longitude in terms of the locations. So let's give this a run. It starts reading in the data. Those are the attributes that it's found. And it starts. It starts splitting nodes. We'll just wait for it to finish. It doesn't take long. Unfortunately, we have I haven't perfected the algorithm yet, and it also just goes to show that perhaps this data set isn't quite suited to this sort of classification. However, I believe that we could get lower error rates. My record low for is 48% error rate, which is still horrible, but I believe that with pruning, we could get that down to maybe 30% error rate. However, we didn't have enough time to implement that. So here is the user interface for testing a single data point. Let's say the month is 6th June. The hour, let's say it's 4 in the morning. Location description, we'll look at what we have here. It could be any one of these. Let's choose apartment. Latitude, Chicago is around 41.8 latitude, so and it predicts a class of battery, but again, high error rate, so it's probably wrong. As for what I did for this error level, I took 85% of the entire set and used it as a training set, and then the rest of it I used as a testing set once I was done training it. Thus, we see here we get 85% of the records. We randomize them because they're actually in order in the in here by date. So we got to randomize them a little bit, and then we split them at the index that we found. And that's the user interface code. Yeah, that's it. Thank you for listening. Bye.